Before we start, I want to go to the very bottom here, this unit circle practice. You're going to want to review your trig notes and make sure you do this. Fill in each coordinate pair, write all the angles on solid lines, radians on dotted lines, and I'll put the answer key online. So make sure you do that using your trig notes to review. You also want to download Know Your Angles from Self-Service. That's going to be the app for you to practice speed quizzes. So make sure you do these two things, and then this will be important for understanding the trig chapter. Okay, so let's get right into it. So quickly, we're going to review converting degrees to radians. So hopefully you remember what a radian is from trig class. If you forgot, that's okay. A radian is the angle created by laying one radius unit on a given circle. So here's a given circle right here. What we're going to do is draw our radius in. And imagine I take this radius and I lay it like right here. So that'll be relatively to scale. The angle we just created right here, that is called 1 radian. Hopefully you remember this symbol. That is a Greek letter theta. And again, by doing this, this is also equal to 1 radian. And notice that this is drawn relatively to scale. So 1 radian is approximately 60 degrees. And what we do is we say 3 radians. That's approximately 180. And that's why pi radians is exactly 180 degrees. So in terms of studying, this is the one that's like crucial, we must understand. And then these two are just like the concept behind it. So remember, pi is roughly 3.14, and that's why we say 3 radians is approximately 180, whereas pi radians, that's exactly 180 degrees. So for conversion, hopefully you recall this from trig. If you're trying to convert from degrees to radians, all you do is you multiply by pi over 180. So I'll put a note here, pi over 180. And we can convert these all pretty quickly. So that's pi over 3. Do the same thing here. That's 5 pi over 6. Same thing here. Negative pi over 4. Pi over 2. And this one's kind of weird. We'll work this one out. 107 times pi over 180. Notice that there is no common factor between these. So the answer is simply 107 pi over 180. Now you also notice that none of these have labels, and that's fine. In terms of trigonometry, no label implies radians. So that's like the one time in math you don't need a label, because if you don't label an angle, we actually assume it to be a radian because it's so common. So all these answers would be considered correct. Now let's go the other way, convert to degrees. So we just flip it, multiply by 180 degrees over pi. So pi over 6, we multiply by 180 degrees over pi. That cancels, left with 30 degrees. Note how I'm putting degrees here. You do need to put that. If you just put 30, that'll be 30 radians, and that will be wrong. So keep going, same process. You get 270 degrees for this one, and negative 135 degrees for this one. So I'm going kind of faster just because this is from trigonometry, so these are all things you should be pretty comfortable with. If you do have further questions on this, please let me know, and I'll go through it slower with you. Now here, we're going to have even and odd functions. So quickly, let's remember even. Cosine is even because if you put a negative in there, it does not matter. It just kind of gets rid of itself. And odd, that's going to be sine and tan. And if it's odd, what happens is these negatives, they will basically come out like so. So you get negative sine theta, negative tan theta. So formulaically, that would be what even and odd functions are. So I'll put a box over here for us. Now, of course, I want to show you why that is. It all kind of relates to the circle. So imagine you have a circle right here. Let's pick a generic point right here. Let's call this x, y, and let's call this theta. By looking at this, we understand that cosine of theta, as long as this is the unit circle, meaning the radius here is 1, cosine theta is x. Sine of theta is y. Now look what happens when I go the opposite direction right here, and I rotate negative theta. This coordinate is x, negative y. So notice how the x value, if you rotate in the negative direction, is the same, because you're still lined up. That's why cosine is even, because the negative effectively doesn't matter. Versus for sine and tan, look at the y value. The y value negates, which is why if you negate the rotation, this angle here, the negative effectively comes out and negates the entire quantity. That's why you can see y is positive here, but if you rotate down, you can see y is negative here. Now we're going to use that right here. So cosine's even, which means you just take that out. So we want cosine of pi over 4. Now from there, we use our unit circle technique. So hopefully you remember this from last year. Pi over 4 is in the middle. That is a medium x value. That's also positive, which means that's root 2 over 2. Tan is odd, so we're going to take that thing out. That's negative tan pi over 4. Tan is right here. That's a medium value and it's positive, which means it's 1. Okay, next example. Given sine of t is 2/5, cosine t is root 21 over 5. Find each of the 4 remaining trig functions. So for these, let's first write it out. Sine, cosine, tan. And then we have cosecant, secant, cotan. You want to make sure you write it in this order, because notice how the horizontal direction, the reciprocal functions are lined up. So again, this is something you should hopefully remember from trigonometry, so this should be a review. Let's plug in what they told us. Sine is 2 over 5, and cosine is root 21 over 5. That's convenient because that means to get these two, I just got to flip those. So 5 over 2, and this would be 5 root 21 over 21. Now the issue is I got to figure out tan and cotan. So hopefully you remember this, that tan of theta, that's equal to sine over cosine. That's called the quotient identity. And then that would imply that cotan of theta is simply cosine over sine. So knowing that, we just divide these two. That would be 2 over root 21, which is 2 root 21 over 21. And I wrote this out because flipping this is much easier, because that will tell us that cotan is root 21 over 2. And there's our values. Now we go to example 7, using the periodic properties. So periodic just means it's kind of like a circular property. So the idea here is going to be, if you have some sine function, you can add and subtract 2 pi freely, and you get the exact same thing. And that's because that's a full rotation, or in terms of graphing, a full period. And then cosine, that's also true because cosine follows a unit circle. And for tangent, that is also true. So for all the trig functions, because they're on your unit circle, all of these things hold true. You can do all of that. So I'll put a big box here. Those are your periodic properties. So I'll show you how we can use that here. So for this one, I'm going to subtract 2 pi, 8 pi over 4. So now I have sine of pi over 4. Now I can do my unit circle method. That is the medium value, which is also the y and positive. So it's root 2 over 2. For tangent, I'm going to add 2 pi. So add 8 pi over 4. So now I have tan of 3 pi over 4. That's in quadrant 2 in the middle. So that's a medium value, and that's negative tangent, which means the answer is -1. And then for tangent, you might recall tan's kind of special. We can even go further, and tan actually follows this. And we'll talk about this later in the class, but you'll notice that the tan one, you can actually go to pi, and that's because the period of tan is shorter than sine, cosine. But that's a very fine detail, and we'll get to it later. For now, you can just use the 3 simple ones I laid out here, and you'll be fine. Okay, so good luck on the questions. I went through these kind of fast, so I am relying that you look through your trig notes, that you remember however you did your speed quizzes last year. But if you are having issues with doing these types of questions, make sure you contact me so I can help you.